Hi, good morning. This is Mr. Willis, and I'm going to talk with you today about metric units, metric conversions, and a technique and tool called dimensional analysis. So let's dive right in. When we talk about the metric system is based on powers of 10. And so that actually makes it very convenient to switch back and forth between one metric unit and another. In customary units that we use in English, switching from inches to feet to miles, it's all different multiples and different conversion factors, whereas in the metric system, it's all a power of 10. And so that's part of what makes the metric system so convenient and one of the reasons that we like to utilize it for science and other measurements. Okay, so as we talk about the metric system, it is also based on a system of prefixes and then roots. And so the prefixes are going to be things like kilo, as in kilometer, milli, as in millimeter, centi, as in centimeter. And so those are going to be some prefixes that you'll encounter. And then your root words are going to be your root units or your base units. And that's going to be things like meter, liter, and gram. Now, as we look at our prefixes, there are many other prefixes that could come into play. So those are not the only prefixes that are available. And of course, these are not the only roots, but meter, liter, and gram tend to be the three most common that you will encounter. All right? So, and of course, the gram is the unit of mass. The liter is a unit of volume. And a meter is a unit of length. All right, and so that's a quick introduction to those root words, to those base units, and what they are used to measure. All right, so let's dive right in then in terms of what how those can fit together. So let's say that I would like to measure a distance, and that maybe I have a distance of 1,500 meters. All right, but perhaps I would like to express that a little differently. And so we're going to look at the relationship between kilometers, millimeters, centimeters, etc. So you just keep in mind up here that I've said that I have 1,500 meters, and we will adjust that into some other units based on different prefixes. First, let's talk about the prefixes. And I'm going to make a list of a few common prefixes. Kilo, deca. Sometimes you'll see this spelled with a C, sometimes you'll see it spelled with a K. I'm going to spell it with a C today. Whoops, and I've put that in the wrong spot, so let me erase that real quick. Whoops. Okay, so it should be kilo, hecto, then deca, and then we come to our base unit, and that's going to be your meters, liters, and grams. And then the next one that we'll encounter is deci, and centi, and milli. Okay, now I've written those vertically on purpose, just so that we can conveniently do a little vertical stacking and learning about that. So let's see. I'm just gonna put a few dividing lines in between there. and that will hopefully help keep things straight just a little bit. Now, kilo is actually a prefix that means 1,000. All right, and so if we have a kilometer, we literally have 1,000 meters, because the prefix kilo literally means 1,000. And so when you say a kilometer or a kilometer, you are literally saying 1,000 meters. You just are saying it in Greek and Latin instead of in English. So when we talk about kilo, that's 1,000. When we talk about hecto, that's 100. When we talk about deca, that's 10. When we talk about the base unit, that actually then is 1, or just the amount that it is. So it is what it is. Didn't get a straight line there. That's okay. Deci then is 0.1 or 1/10. Centi is 0.01, and milli is 1/1000th, which is 0.001. And so you can see that this is multiples of 10, and it's just like bumping the decimal along from one place to the other. So you can see if I took this milli and bumped it over one, I would have the centi. If I bumped it over one more, I would have the deci. If I bumped it over one more, and so on and so on. I want to point out something else that this does is kilo, even though it's 1,000, we could also express that as a power of 10, meaning 10 to the third power. 100 could also be expressed as 10 to the second power. 10 could be expressed as 10 to the first power. 1, of course, anything to the 0 power is 1, and so we could express that as 10 to the 0 power. Now, 0.1, 1/10. If I had 1 over 10, you see that would be actually the same as expressing that as 10 to the -1 power. Remember, because 10 to the first power, and then if I want to move it to the other side of the fraction, we just change the sign on the exponent. And so that would be the same as 10 to the -1st. All right, so I'm just going to, so I wanted to show you how that happened, but now I'm going to express that as 10 to the first, 10 to the -1st. So 10 to the -1st, this one is 10 to the -2nd, and this is, of course, 10 to the -3rd. So you can see that we have prefixes which stand for a certain power of 10 and a certain multiplier. Okay? But we can express that in terms of prefixes, or we can express that in terms, we can express it in terms of multipliers, or we can express that in terms of power of 10. So just as I had 1 kilometer, which meant 1 times 1,000 meters, because the prefix kilo means 1,000, I could also substitute kilo for 10 to the third. And that, of course, would still equal the same 1,000 meters that I had down here. And so we can see that those are equivalent. All right. So let's see. So let's look back at our 1,500 meters and see what we can do that. Hopefully you have these prefixes and roots and this little example copied down, because I'm going to now do my best to erase them all in one fell swoop. Let's see if I put that in a square and then hit delete and see if that does that. All right, great, it did. Learning something new about my technology every single day. All right, so let's go ahead and bring this over and say that I have 1,500 meters. And I would like to convert that into kilometers. what I'm going to do is I'm going to take my 1500 meters, and I'm just going to look at this little chart with my prefixes, and I'm going to say, hey, I'm starting with meters. Tell you what, let's switch to maybe another color. Let's switch to this kind of baby blue. So I've started at 1500 meters. Okay, and so that is my base unit. So I'm right here. All right, and I would like to go to kilometers, and I just need to say to myself, how many steps is that? This is one way to do that. And I say, okay, it's 1, 2, 3 little hops. Okay, 3 little hops to the left. So what I'm going to do is I'm going to take my decimal that I know exists there, and I'm going to hop it 1, 2, 3 spots, and so then I'm left with 1.5 kilometers. And that makes sense because if we took 1.5 kilometers and expressed that as 1.5, remember kilometer is 1,000 meters, then sure enough 1.5 times 1,000 would in fact be 1,500 meters. And so you can see that that 1,500 meters and that 1.5 kilometers are indeed equivalent amounts. Now, what if I wanted to take that same 1,500 meters but wanted to express it as centimeters? Okay. Let's see. Let's switch once again. We'll switch to a nice yellow color this time. So I want to go from 1,500 meters. Again, meters is going to be my base unit, so I'm starting off right there, and I'd like to go to centi. And so I'm going to look and I'm going to say, well, that's 2 hops to the right. So I will take my 1,500 and the decimal that I know is there, and I will hop it 1, 2 spots to the right, and then I'll fill in those spots with 0 placeholders. Okay? And so at this point, then I'm going to say, okay, 150, let's see, excuse me. Let me see if that's, yeah, sure enough, got the correct number of zeros, and that is 150,000 centimeters. Okay? So what I want to point out is if we start with one value, 1,500 meters, if we move to a bigger unit, like kilometers, because a kilometer is a bigger unit, if we move to a bigger unit, we will get a smaller number. But if you move to a smaller unit, like centimeters, a centimeter is about the width of your pinky fingernail, and so that's smaller than a meter, which is about a yard, and a kilometer, of course, is 0.6 miles. So you know, if you switch to the bigger unit, you get a smaller number, but if you switch to the smaller unit, you get a bigger number, because if you have a bigger measuring unit, there are fewer of them. If you have a smaller measuring unit, then you need more of them to cover the same amount. All right, so that's a quick look at the introduction of the metric system. Something else that I want to mention to you guys is that if you want an easy way to remember this KHDBDCM, there are all kinds of little mnemonic devices, little sentences that you can make up. The two that are my favorite are King Henry danced badly down Center Main. Okay, and you can imagine someone close to my age attending a TikTok dance party down Central Main, and it would be awful. It would be bad. But if you don't want to remember that, you can remember King Henry died by drinking chocolate milk. It's a little more morbid, but it's certainly a visual image that I think will stick in your mind and help you remember. So King Henry died by drinking chocolate milk. There you go, and that will help you remember that relationship between 1,000 and 1/1000th in terms of those. Just a couple of others that you may run into. A micrometer or a micrometer is actually 10 to the negative 6th meters. Okay, and then there are some other prefixes and suffixes that you may run into, such as if you want to go to larger ones, we have mega, which is actually then 10 to the positive 6th, or giga, which is where the term gigahertz and gigabytes comes from, which is 10 to the 9th, and of course tera, which is 10 to the 12th. And if you go the other way, then you go from micro to, I believe the next order of 3 is pico. No, it's nano and then pico. But I'm not going to write that down because I am not 100% certain. I'm only like 85, 95% certain. So you can look up metric prefixes using Google or in a reference in your textbook. All right, let's clear that off again. And I tell you what, in fact, I'm going to clear the whole screen now, and we're going to move to something called dimensional analysis. All right, so we're going to move to dimensional analysis. Now, dimensional analysis is a technique that is used for conversions. So it is used for conversions and certain types of calculations. Whoops, that's a C. All right, so dimensional analysis is used for certain types of conversions and calculations, and it is based on the idea that the units of a number actually travel with it in equations or in calculations, and your final units actually come from the mathematical process that you moved through the whole way. Let's say that you want to do a calculation about speed. Speed is equal to distance divided by time. Now, most of the time, let's just say, for example, though, that I wanted to, that I was going to cover 100 miles in, well, I'll tell you what, let's say 140 miles in 2 hours. Okay, so 140 miles in 2 hours. And what you can see is that if I take, oh, look, there's the bell. I'm just going to let that ring, just going to embrace it, enjoy it. All right, it's over. So I'm going to take that 140 miles, and we can see that the numbers 140 divided by 2 are going to reduce to 140 divided by 2 to 70. Now here, though, I have some units, and they don't reduce. Miles divided by hours, because remember that fraction bar actually means divide. Okay, miles divided by hours does not reduce to some other, I can't just cross off some of the common letters, like, oh, the S goes what? Nope, can't do that. It's miles and hours. And so we just keep both, and we express it as miles per hour. And so you actually keep both units, and you even keep the dividing or the per line. And so that's what happens there. The number reduces, the units don't reduce, and so you have that for both of them. All right? The key to dimensional analysis is we can actually set things up in a way that they will reduce. All right? So let's look at what we did a minute ago when I had 1,500 meters, and I want to convert to kilometers. Ooh, that's a terrible line. Sorry about that. And I want to convert that to kilometers. What I'm going to do is I'm going to put in here a conversion factor. Now let me just come up here and mention something. You know that if I take any value, like let's say that I have a value of x in algebra, and I multiply it by 1. Okay, that then is technically 1x, but we actually leave the 1 out and just express it as x. What I want you to remember is that if you multiply something by 1, you're not changing its value. And so it is always legitimate to multiply something by 1 without changing its value. And something that we do, in fact, is often we'll use that to change denominators in fractions. So if I have 3/5, but I am going to add that to, say, 4/10, well, I can't just add those directly because they're not common denominators. And so I need to make a change. And what I'm going to do is I'm going to change this. So I'm going to take 3/5 and I'm going to multiply it by 2/2. Because 5 times 2 will then get me to 10, which will be my common denominator. And 3 times 2, of course, will be 6. And here's what I want you to know. You know and are aware that 6/10 is equivalent to 3/5. And the reason that those are equivalent is because I transitioned from 3/5 to 6/10 by multiplying by 1. You see that is still multiplying by 1. It's 2/2. And so it is legitimate if you have equivalent values to multiply, and it's as if you're multiplying by 1. You're not changing the value of the item. So I'm going to take 1,500 meters. Okay, so Mr. Willis, what does that review of my 7th grade fractions and Algebra 1 have to do with anything? I'm so glad you asked. All right, so we're going to look here at, I'm going to take 1,500 meters, and you remember that 1 kilometer was actually equivalent to 1,000 meters. Okay, and so what I'm going to do is I'm going to set this up. Ah, yes, there's that fabulous bell again. Love it. Okay, so we've got our 1 kilometer and our 1,000 meters. And I'm going to set this up just like a multiplication and division problem. I will take 1,500 meters and multiply by 1 kilometer. Well, 1,500 times 1 will give me 1,500. And here, I don't have anything here. There's an implied 1, because remember, you can always put something over 1. So if you want a placeholder, you can put a 1 there. 1 times 1,000 meters is going to equal 1,000. And I still have my dividing line. Okay, so I'm getting 1,500 divided by 1,000. Here's what I want you to see. My meters are in both the numerator and the denominator, and so they will cancel out. And I'll be left with only kilometers. So I have 1,500 divided by 1,000. Oh, well, 1,500 divided by 1,000 is 1.5. And I have kilometers as my remaining unit. So that will then equal 1.5 kilometers. Okay? Realize I wrote that kind of small and off to the side, but just trust me, it says 1.5 kilometers. And that's what you get when you do the division and cancel out the units that are in the numerator and the denominator. All right. So let's do another example of that. We are going to, let's see. I'm gonna pick up a few of these things here. And oh my goodness! All right. There we go. Great. All right. So we're going to do another. Now, if I said that I wanted to convert 5 minutes into seconds. Okay. Well, you say, Mr. Willis, we don't need to convert. I'm very good at math. 5 times 60 is 300. And so it's just going to be 300 seconds. And you're correct. Congratulations on your math genius. Well done. All right, and that's because you have memorized the fact that 1 minute is equal to 60 seconds. Now let me show you what that would look like as dimensional analysis, just to use our example. Okay. Okay, and so we've got 5 minutes, and then I made that line a lot longer than it needed to be. Sorry about that. 1 minute is equal to 60 seconds. Mr. Willis, how do you know whether to put the 1 minute on the bottom or the 60 seconds on the bottom? You always want to put it so that whatever you're trying to get rid of will cancel out. And so I want to set it where my minutes will divide away, and then I'm going to have 5 times 60, and that, of course, is 300. The only remaining word, the only remaining unit is seconds, and so that's how that would work with dimensional analysis. Mr. Willis, that is way too much trouble. Ain't nobody got time for that because we just know that 5 minutes is 60 seconds. Thank you. That is wonderful. I'm, again, very proud of you. However, what if, instead of doing 5 minutes into 60 seconds, what if I did, what if I did, let's see, 15.7 years? What if I have a student who is 15.7 years old, and I would like to know how many seconds that student has been alive? Okay. All right, well, do you happen to know the conversion factor for years to seconds? No, me neither. Hey, so what we're going to do is we're going to put 15.7 years right up here. And I'm going to put my, oh, look, there's a nice neat bar. And I'm going to put that in there. Now, I'm trying to get to seconds, so what I'm going to do is I'm just going to work to gradually smaller and smaller units of time using units that I know. And I happen to know that 1 year is equal to 365 days. Now that's the unit conversion we're going to use. It's actually 365.25, but we're just going to stick with 365 for convenience. Mr. Willis, why didn't you put 12 months there? Because a month is a non-standard unit. Some have 31 days, some have 30 days, some only have 28 days. And so we need to go with something that's a standard unit, and 1 year to 365 days is a standard amount. All right, again, I put days on top because I needed my years to be underneath so that my years will cancel in just a moment. So if you want to kind of cancel as you go, you can, and you can see that my years are going to divide away, and then I will be left with days. Okay, so let's, all right, now we happen to know that 1 day, and again I'm going to put the days underneath so that it will cancel, is equivalent to 24 hours. All right, and so I'm going to then get rid of my days. And so now we're down to hours, but I'm trying to get down to seconds, okay? And so let's just continue our march. We're now trying to get rid of hours, so let's put hours on the bottom. I know that 1 hour is equal to 60 minutes. And so my hours will go away, and then I'll be down to minutes. And let's just keep switching colors because that's always entertaining. And now I'm down to minutes, so I need to put 1 minute. And I'm going to get rid of my minutes. Oh, what's that equivalent to? That's right, 60 seconds. Ooh, and so now I have finally made it to my goal. So what I'm going to do is I'm going to do the multiplication all the way across. 15.7 times 365 times 24. Go ahead and do this on your calculator as we're going. Times 60 times 60. Good. And then, of course, we still have to do our division, but since we're dividing by 1 times 1 times 1 times 1, I can do that math in my head and say, hey, that's going to be 1. So I'm going to do that division and know that what I've got on the top is actually going to be my final value. I don't have my calculator with me, so I'm going to let you do the math, and it will be right there for you, and it will be that number of seconds that our 15.7-year-old student has been around on the earth. All right, I hope that was helpful for you. Just a quick introduction to the metric system and dimensional analysis. I'm going to let you do some practice problems on a page that you have there in class or in your Google Classroom, and we'll see you again later. Have a wonderful afternoon.